Hello, welcome to Math with Mr. Dobrescu, to the rescue. I hope everyone had a fantastic summer and now we are ready to start a new school year with lots of strength, and we are going to tackle some equations. Again, our first unit this year starts with solving equations. Simple equations, equations with variables on both sides, and more complex equations. But let's take a look here. Let's take a look at the warm-up for today. We have a problem here. We have k plus 4 divided by 0.2 equals 5. How do you solve this equation? Let's take a look at this problem again, and let's see if we can solve this equation. Remember, and every time we are solving equations, our goal is to isolate the variable. And in this case, our variable is k. And we are going to isolate this k on this side of the equation. So we are going to solve 4 divided by 0.2 first, and then bring that on the other side of the equation. Let's do this first. Let's do this operation first. 4 divided by 0.2. How can we solve that? Some of you guys may be able to do that in your head, but if we don't do that in our head, it's here we have 0.2, right? 0.2 can be written as 2 over 10, right? This can be written as 2 over 10, and then we have 4 divided by 2 over 10, right? And if we simplify 2 over 10, it's the same thing if we divide the top and bottom by 2. 2 divided by 2 is 1, 10 divided by 2 is 5. That's the same thing as 1 over 5, or 1 out of 5 is 0.2, or 20%, right? 0.2 is 20%. 1 divided by 5 is 20%, right? Okay. And then we still have the 4 here, 4 divided by 1 over 5. And remember, 4 can be written as 4 over 1. We can put a 1 under the 4. And with division, remember, we know that saying, keep, change, flip. So we are going to keep the 4 over 1, 4 over 1, change the division into multiplication, and flip the 1 over 5, and that becomes 5 over 1. And now, if we multiply 4 over 1 times 5 over 1, we get 20. So all of this becomes k plus 20. So we have k plus 20, right? K plus 20 equals 5. Okay? K plus 20, this becomes 20 equals 5. And of course, in order for us to solve for k, we have to subtract 20 on both sides. So let's subtract 20 here and 20 here, right? This cancels out, and we get k equals negative 20 plus 5, we get negative 15. Okay, so k equals negative 15. And of course, I told you guys we need to check our answers. So let's check our answers here. So let's check to see if we got the right answer. Now, if we check, remember, we are going to substitute negative 15 into k, original equation, and let's see what we get. So instead of k, we put negative 15, so we have negative 15. Negative 15 plus 4 divided by 0.2 should equal 5. Let's see if we are going to get a true statement. Okay, so of course, here we have negative 15 plus 4 divided by 0.2 equals 5. And we need to remember here the order of operation. So again, we have to do this division first. Okay, we have to do the division first again. So after we did that division, remember we did all the work here and we got 20. So we know for sure that that is 20, right? Because we already did all this work here. Division comes before addition. So all this becomes 20. So we have negative 15 plus 20 equals 5. And of course, Negative 15 plus 20. 20 take away 15 equals 5. So 5 equals 5. We get the true statement. Therefore, negative 15 is the answer to our equation. Okay, so that was our warm-up. And now let's take a look at these two more problems here. Here we have 5 over 6 equals 1 over 3 plus b. And in this case, we need to solve for the variable. And we see that the variable is on this side of the equation. It doesn't matter which side of the equation the variable is on, we can still solve for that variable. So let's get this d isolated on this side of the equation. Okay? And let's see what we get. And of course, in order to get the d by itself, we need to get rid of 1 over 3 by doing the opposite, by subtracting 1 over 3 on both sides. So let's subtract 1 over 3 on both sides, minus 1 over 3, and let's see what we get. 1 over 3 and negative 1 over 3 cancels out, so we get d equals, and let's do this operation by the side here. We have 5 over 6 minus 1 over 3. And in this case, we have to get the common denominator. So between 3 and 6, we know that 6 is the common denominator, right? So 6 is the common denominator. So we need to multiply this 3 by 2 to get to 6. Whatever we do on the bottom, we do on the top. And then we have 5 minus 2 times 1, 2. 5 minus 2 is 3. 3 over 6. And of course, we need to simplify that. 3 over 6 can be simplified if we divide top and bottom by 3. 3 divided by 3 becomes 1. And 6 divided by 3 becomes 2. 1/2. So d equals 1 over 2. This is our final answer. And let's check now. Remember to check this equation. We go to the answer, which is 1/2, and we are going to plug that 1/2 into the d here, original equation, and see if we get the same answer. So we have 5 over 6. So let's check. So we have 5 over 6 equals 1 over 3. Instead of d, we put 1 over 2 plus 1 over 2. And of course, if we add 1 over 3 plus 1 over 2, common denominator is 6, right? We need to multiply this by 2. Whatever we do on the bottom, we do on the top. And this by 3, right? 1 times 2, 2. 1 times 3, 3. 2 plus 3 is 5. So we get 5 over 6 equals 5 over 6. We get the true statement. Therefore, d equals 1/2 is the solution of our equation. Let's look at one more. In this case, we have some decimals. And remember, decimals can be a little more complicated. But let's look at this problem. N minus 1.4 equals negative 6.3. And of course, to get that n to be isolated on this side of the equation, we need to add 1.4 on both sides, so we can get a 0 here and get the n by itself. So let's add 1.4 on both sides. Whatever we do to one side, we have to do to the other side. Okay, if we do that, we know that 1.4 and negative 1.4 cancels out. So we are left over with n equals, now we have a little problem because we have negative 6.3 and positive 1.4. And if we look at these numbers, we know that we have more negatives than the positives. So because of that reason, the bigger number without the sign gives its sign, right? So the bigger number is negative, and we have more negatives. Therefore, in the answer, we are going to have, the answer is going to be negative. And now the rule is this. Once you get the bigger number gives this sign, right? Negative in the answer. Now we are going to subtract the numbers without their signs. So let's subtract the smaller number, which is 1.4, from 6.3. That's what it means. So we have 6.3. We are going to subtract 1.4 because we already got the sign. Bring out the decimal point right away. We cannot take away 4 from 3, so we have to borrow from the 6. make 6 a 5, and make 3 a 13. Okay? So 13 minus 4 becomes 9, right? 9, and then 5 minus 1 becomes 4, negative 4.9. Okay, so that's the answer, n equals negative 4.9. And let's check our work. So in order to check our work, we are going to substitute negative 4.9 into the n here at the top. So now we have negative 4.9. Let's check this. Negative 4.9 minus 1.4 should equals negative 6.3. And obviously, we have two negatives here. If we combine those two negatives, it's the same thing as negative 4.9 add negative 1.4. Let's see what we get. Bring down the decimal. 9.9 plus 4 becomes 13. 3 carry the 1. 4 plus 1, 5 plus 1, 6. That is negative 6.3 equals negative 6.3. And we get a true statement. Therefore, negative 4.9 is the answer for our equation. I hope you guys found this very useful, even how to do this type of equation for the warm-up, and then working on a little bit more complicated equations involving fractions and involving decimals. Thank you all so much for watching, and please don't forget to like and subscribe and stay tuned for our next video. All the best to you.